Hello everybody, it's Mr. Allred here. Today we're going to solve systems of equations, and for when I made this lecture it's coming right out of having learned to graph lines. So we're going to kind of tackle this in a certain format. We're going to solve our systems on a graph, which more or less is going to be just the explanation. And then we're going to have two methods. Substitution and elimination, and then we're going to have our other types of answers to come out of this, which are contradictions and infinite solutions, which will make sense when we get to what these systems are. So, what is a system of equations? Well, a system is more than one equation with more than one variable. So what I have down here is two equations. I have y equals 2x plus 1, and I also have the equation y equals negative 3x plus 6. So I have two different equations, and from my previous lectures, these are two lines because they're both in that y equals mx plus b form. That's how we know they are straight lines. But you see a y in both and you see an x in both. And what we're looking for here is we're looking for a solution with the same x and y for both. Okay, so we need a value for x that also gives us a value for y that match up in both equations. Now over here to the right, I have a graph, and I have both of these lines graphed. The red one is 2x plus 1, and the blue one is negative 3x plus 6. And we see these two lines cross each other if we were to graph them. Okay, and we could use the y-intercept and the slope to graph them. But where do they cross? They cross at a point that is 1 for x and 3 for y. Well, that is the x, y value that would work in both equations. So that is the solution. X being 1, y equals 3. And we could plug 1 and 3 into y equals 2x plus 1 and see that it balances. It gives me 3 equals 3. I could plug them into y equals negative 3x plus 6 and see that it balances. So that pair of numbers works in both equations. So it is a solution to the system. Okay. Now, something that we should note is that we may not be able to graph very easily any equations we're given, and it may not even be necessary or desirable to graph them. So there must be other methods, because even if we can graph them, we might not be able to pin down where they go. So let's see here. So like I said, because there's more than one variable and more than one equation, it's kind of hard to guess your answer. So sometimes when you have a simple equation with one variable, you can mentally move some numbers around and figure out what the answer could be. Well, here, because, like I said, two variables, two equations, that makes it much more difficult. But the good thing is that we have two algebraic methods for solving these. That means we're going to have an algorithm for solving these systems of equations. Okay, it won't be guessing, and it won't necessarily be graphing either. So let's go into our first method, which will be substitution. So we're going to solve our system by substitution. So here's the steps that I'm going to give you, and there's 4 steps. And we're going to go through them when we get to an example. But we're going to solve one equation for one variable. Okay, so in the previous example when I gave you 2 lines, they were both y equals. They may not start off by themselves or in a desirable form. But if you think of them as formulas, you can always get a variable by itself. So we're going to solve one equation for one variable. Then we're going to substitute the new equation in for the variable in the other equation. So if we solve in step 1 and we got x by itself, we'd have x equals something with a y in it to the right. We would take that representation of x and plug it in for x so that our new equation would only have y's in it. And it would only be one equation with probably y's on both sides, possibly. Okay, but that'll leave us one equation, so we'll solve it. And then that just gives us, in the example I was talking about, it just gives us y. So we're going to plug in our solution to get the other variable. So if we solve for y to start with, we'll plug that into our original and see if we can find x. And if we solve for x to start with, we'll plug it in and see if we can find y. And technically, it does not matter which one you solve for first. Usually there'll be one that is obviously easier, but that's not always the case. So let's see if we can get through this method. So here's an example of I have solved by substitution. And I just want you to be familiar with both methods. So I may not always tell you how to, or which method to use, but it's good to know both methods. So in the first one right here, I'm going to solve one equation for one variable. So I'm going to take the first one, since I see that x there doesn't have a coefficient, and I'm going to solve the first one for x. Okay, so I said I'm going to solve one equation for one variable, and if I do that, I'm going to move the 5y over. The equations are x plus 5y equals 15. That's the first one, and that's the one I'm going to solve and get x by itself. Okay, so when I do that, I'll have x equals 15 minus 5y. Okay, the other equation is 2x minus 3y equals 4. So what I'm going to do is I'm going to take this representation of x, which is 15 minus 5y, and I'm going to plug it in for x in the other one. So I'm going to plug 15 minus 5y in for x in 2x minus 3y equals 4. So when I do that, I'm going to have 2 times 15 minus 5y minus 3y equals 4. Okay, and now this equation is all in terms of y. It's one equation in terms of y. So let's see here. Next we want to solve this thing that we've got. 2 times 15 minus 5y minus 3y equals 4 for y, so that we can get the actual value. So when I do that, I'll distribute. I'll multiply through by the 2, so it'll be, let's just mark that out. We'll have 30 minus 10y minus 3y equals 4. So if I clean this up, I'll combine my y terms, and on the left I'll have negative 13y. And if I subtract 30 to bring it over to the other side, I'll have negative 26 on the other side. So I'm solving for y, so I'll divide both sides by negative 13. And I get y equals 2. Now I'm running out of room because there's my face. Let's move my face in this video. Maybe we can move it back in the next one. So we'll go to step 4. And now we'll say plug y equals 2 into, and it doesn't matter which one. Let's see, y equals 2 into, let's just use the first one. Let's use, the first one. X plus 5y equals 15 to find x. So I'm running out of room here, so let's see if we can do it creatively. So if I plug in y being 2, I'll have x plus 5 times 2 equals 15. So that's x plus, x plus 10 equals 15. I'll subtract the 10 from both sides, so I'll have x equals 5. So in the end, I got a solution of x being 5 and y being 2. Okay? I know that's a lot to take in. Let's do the next one. Hopefully we got enough time. Let's put me way up in the corner. I don't think we have time on this video. We'll pick it back up on the next.